Welcome everyone. In this video I'm going to introduce you these displays. These displays were provided by DWIN, so these are some kind of promotional materials. So this video will be about these displays. I will show you how they work. I will also show you some kind of tutorial about how to program them and how to communicate with them. And I will also try to have a fair review about these displays. So I will tell you about their pros and contras as well. And despite the fact that I received these displays for nearly free, I had to pay for the customs and the posting services. I'm trying to make this review into a fair review. So about these displays, as you can see, I have these two displays. This is a 3.5 inch unit and this is a 7-inch unit. I picked these displays myself from their web shop or warehouse, and then they provided it to me. And I also asked for this serial converter, which allows you to connect any of these displays to the computer via serial port. So there is a chip on this circuit board which basically does the communication between the display and the computer. And of course I got a USB cable, so I can connect this unit to my computer. And these displays are actually quite nice in a sense that the display itself, it has gorgeous colors and very good resolution. I will put the details about this display and this display somewhere on the screen down here. So you will see the resolution and other important details about them. And what is very important about this chip, which drives the display, is that it is the company's own chip. It's called T5L, and if you go to their website, I believe that you can read more information about these chips. But these are some 2-core or double-core, dual-core chips, and one core takes care about the display and the other takes care about the operation system, so it works quite seamlessly. It's very nice. And then what we have to know about this is that it has an SD card slot, and on this type of display it has a very important role, because you can only program them by using the SD card. So you have to copy a bunch of files on an SD card, plug it in, power up the display, and then let the display process the data which is on the SD card. And then you will have your user interface on the display. And then some units, this specific unit doesn't have it, but some units have wireless option as well, so it depends on what you buy. And then you see that I have already attached 4 cables to this display, because it also has serial connections. And one option is to use this circuit with the ribbon cable, and then that's where you can communicate with this thing via USB, basically. Or if you use these 4 cables, 5-volt, ground, TX and RX, you can, for example, connect it to a microcontroller. In this video I will not show it how to work with it via using it with a microcontroller, because it would take plenty of time to explain everything. But I will show you how to program this and how to display values or take some kind of values like interaction with the display from the display via the serial port. So that's all. It also has, let's say, expandable flash memory, so then you can put on a bunch of video files, sound, and all these things. It also has a buzzer here, so it beeps when you touch the display, and it can also play sound if I'm not wrong. And the only difference between this display right here and this bigger display is, from these tutorials or introductions perspective, is that they are just different in size, but in principle they have the same kind of features. So we have some connector for this ribbon cable here. I can also solder some TX and RX and 5-volt cables here. It is a bit more difficult for this display than for this display because there are no holes for it, but I can do this, it's fine. And of course we have the SD card slot, which is important for programming. So this is, yeah, just a larger display. And I always wanted to have a larger display because I have my old project, which is a DIY tensile testing machine. And this display will be perfect for that project because then I can basically ditch using the computer and I can control my tensile testing machine using this display. So that will be in a future project. Stay tuned because it will take some time to learn it. But the main point of this video is that I'm going to show you how to use this display. But in order to do that, I will move to my computer. And one camera will show this display and how I interact with it. And I will also record my display, my monitor for my computer. So you will see where I click or what I do in order to put the program on this and interact with the display. So let's go to my computer and let's see how to work with this guy here. So we are in front of the computer and this is their website. And the reason why I show it to you is because one of the most important things that we have to do before being able to edit anything is that we have to get the tools for the display. And that is on their website. So we just simply go to the download and the tool section, as you can see it here. And we have this T5L DGUS section. And what we do here is that we have to download this XR21 blah 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 driver. This will be the driver for that tiny board which I showed you, and that connects your display to the computer via serial port. And then we have this DGUS V7640, and this is the development or developing environment. And once you have these things, you select a folder on your hard disk, and first of all you install the driver. That is just an installer, and this DGUS software is a portable executable, and it's auxiliary files. So then you just unpack it somewhere and use it as you would use a normal software. So for example, this is how the unpacked files look like. So for example, this is the executable, which I will run in 1 minute, and then a few extra folders for storing the files and a few extra files. And you can see already these selected folders here. This is what I created. So these are just some random folders which store all the files necessary for the display. And these are, we can call them as project folders. So whenever you create a new project in the software, in the tool, that folder, for example, will end up here. But of course you can save it anywhere else, but I think this is a good way to store it. So let's keep this folder open. And now I just open the executable and we will see what we will see. So now this is the main display of the software. And as you can see, it has a lot of options that we can choose from. So I will explain you everything step by step. So at the top we have these tabs or menus for the different options. We will go through some of these modules, but not everything, because otherwise I would sit here for a day to explain everything. But we have everything here to write the software for the display. Then we have this welcome tab. So we have these two icons, new and open file. So if we have previously already created a project, then the open file will open the project. Or we can press new and we can create new projects. And here is a history. Obviously I censored some of the folder names, but you can see that I have these already created, let's say, test folders. So I was just fooling around with different projects and so on. And you can directly open them if you want from this history part. And then what is important here on the starting display is this DGAS config tool field. So we have this 0 hash word bank generating, and this is one of the most important tool, because this will generate the fonts which will be displayed on the display. And then we have these pictures conversions. This is also important because whenever you create a page, here you have to create a picture, and then you have to select a certain field on the picture which will be, let's say, manipulated, or you will interact with that certain part of the display. So that's also important in my opinion. And then what is also important here is the UART download tool. When we want to exchange config files between the computer and the display. We cannot program the display from USB. We have to use the SD card, but we can upload config files. So if you, for example, already created the display and everything, but you have to change the behavior of a button, let's say a button, then you can do that by just manipulating the config file. But you cannot replace the files which you have uploaded via the SD card. And then we have this ICR Generator. So this will create a so-called ICL file from the pictures. So it will compress them and convert it into DWIN's own format. And then we have a bunch of other options which I don't care about right now because, yeah, as I said, it would take ages to explain everything. So let's create a new project. So I press new here, and then I get this window where I can select the screen resolution, and I can select the path, so the project folder. And then here I want to show you a very funny part, is that first of all I don't find this resolution, which is the resolution of my display, on this list. Or actually now it's there, but previously I did not find it. So I could click here and select it, but in fact you can type in this manually, and you can make the software crash. You can see it, but it doesn't crash, but it just throws an unhandled exception. So it's very sensitive for the letters, so you have to use a capital X here and it will be fine. And then I press these 3 dots here, and then I go to my folder, the DGAS folder, and under this DGAS folder now I just make a new folder which I will call YouTube demo. Then I pick this folder as my folder for the project. So now here you can see the path. Then I press OK. So now we are here, and we started to have a bit more options. For example, we get this new tab here which is called Touch and Display Config. And this will be where we have our display, and we will add the areas to the display. But before doing anything with the display, before even loading the picture which will represent our user interface, we go back to the Welcome tab, and then we go to this word bank generating tool. So now we have this font generator, and if I'm not wrong, the goal would be to scale the letters in a way that they don't leave their field. So you can see that most of the right side of the letter A is missing. And in order to squeeze it into its available space, we can play around with the scale and the shifting. And by manipulating those values, we can squeeze it back to fill in these fields properly. But the letter A is not wide enough, so what I would suggest is that let's choose W. That's one of the widest character in this list. And then we will try something. So you can see that half of the letter is missing. So if I would have fixed the shift and scale parameters for the A, the W would be still wrong. I can show it later. But here I just go quite randomly. I just start to change the horizontal scale, and you see how it behaves. And I change the vertical scale a little bit. So now it looks quite okay. But if I go back to A, that looks already quite nice, as you can see. So this is fine. And if you want, you can also change the font and everything, but I don't care about this right now. So I just picked the default font, fixed it into the available space. And now all we have to do is we click on the create button. And now here you can see some progress. So the program is building all the fonts. So we have to wait here. So it's finished. This is okay. So now as it is done, we have to go to the File Explorer, the Windows File Explorer, and navigate to the project folder. So here it is. I opened the project folder, and here you can see that our file is generated. But I really recommend you to move this font file into the project folder. So what I will do is that I know that I created this YouTube demo folder right now, so I just take this file and just move it there. And now I just open our YouTube demo file or folder here. And you can see that it is already kind of occupied by a few files and folders, but this will keep growing as we progress with our folder. So now let's go back to the software. So here I still stay on the welcome page, but now I go to this ICR Generator. And then we get this window. And in this window, we have to select the background picture, which will be our user interface. So I will do that by clicking here on the select picture. And as you can see, this, let's say, button navigates us to the DWIN set folder of our project. And that's very good, but we don't have any images stored here. So I will just go to the image folder and just grab my image, which I have already prepared. So I copied in this file here. You can see the file, and then I just open this. So now this background image is there. It's very important to have the 00 as the first two characters for the file, because this is how the display will be able to identify the picture in this compressed file, which we create now. And if you have multiple pages or multiple icons or whatever, you will have a bunch of items in this list. But now I just have one page, one simple background. So I just have this one with the 00 ID. So all we have to do here is just we generate the ICR file. And now you can see that this window tries to drop us back to this image folder. Instead of that, I go back to the project folder and go to this DWIN set folder. And here we know from the manual of this tool that this file has to be called 32 and then something something. So I just call it like 32 background. And the 32 is again important for the display. So its software will be able to identify this config file, and it will know that whatever is stored in this file is related to the pictures. So I just do this, save. It's finished. Done. So now I can go back to my project. So we are here. The whole thing is empty. So I just open the image again by adding it here. So I'm adding it from the project folder. And now we have this thing. So once again, this display, or the concept of the display, is a bit unusual in the beginning. So how this works is not as usual as, for example, putting together a PowerPoint presentation where you can drag and drop different items like buttons, boxes, arrows, and animated objects and so on an area, and then you can modify their properties. But here you have to use an editing software like GIMP or Paint or Photoshop, and you draw your user interface. And after you drew your user interface, you have to do this uploading and ICR generating process. And then you load your image like I did it right here. And you have to add layers or boxes on top of this image. And the behavior of those boxes will determine what your display does. So for example, here you can see that I have two texts. One says ADC value, another says slider value, and each of these texts has a blue area under them. And that's where I'm planning to put numbers. Then you can also see that there is a green band or rectangle here, and that is an area which I will use as a slider. And what my plan is to, let's say, show you two ways of communication, sending and receiving data. So in the ADC value field, I'm planning to print some kind of number. Now I will just manually send the number through the serial port to this field. But in the future, I will show you how to read, for example, the output voltage of a potentiometer and send it into a similar text box. And then the slider value will be generated by this slider, which I will put over this band. And first of all, wherever I poke on this band, the corresponding value will show up in this slider, but that same value will be also sent to the serial port. So then I will be able to receive it by the computer. And then I will use this LED button here as well. So I'm planning to add a button functionality to this part. And what this will do is, in this demo, it will just send the character to the serial port, but in an upcoming tutorial, it will toggle an LED on and off. So how this works is that we have to go and we have to kind of fill in these fields. And that is done by the display control menu. So here we have to select whatever we want to display. And we know that I want to display a data variable. So I have this, click on this, and now you can see that the icon is different. And what we can do is that we have to select an area which we want to, let's say, accommodate with the variable. So now I'm just dragging a rectangle over this area. And then here you can see on the right hand side that we got some new option, and this is actually used to customize our field and its behavior. So in these four boxes, for example, we can just set up the physical parameters of this box. So where it is placed on the display, that's the XY. So it's just its simple coordinates, and then the width and the height is just the physical dimensions of the box. As usual, if you want, you can change the name. So for example, we will call this ADC value. And then we have this SP and VP. And these are actually addresses in the RAM of the display. And what the SP does is it is called description pointers. So if you read or write a value from the address which is associated with the SP pointer, then you can change the description of this box. So for example, you can change its dimensions, you can change its color, and anything which describes it. And then we have this VP number, which is variable pointer, and this is also a RAM address in the display. And you have to be careful because you don't want the VP address to overlap with the SP address. They can. So then the VP address stores the variable. And how the display works is that you send a command to the display that you want to read or write, and then you send which address you want to read or write. So for example, now in this demo, I should give an address to this VP control, so to this box, and then I can access that VP address by the serial port, and for example send a data to it. And actually that will be the point here, that I will be able to send some value to this address, and that's what I will show you. And in this tutorial, let's make this 2000. So if I will try to reach this 2000 address by the serial, I will show it how it is done. Then I will be able to send a number into this box. I will just change the color of the fonts here. The word bank ID is the font ID, which I just generated a few minutes ago. So if it's 0, then I use the file which starts with 0. And we can generate plenty of fonts, and then we can choose its serial number. Font size, I will choose 50 because that's large enough. And then I leave everything unchanged because I don't care about this, but the integer digits should be 4. Because, for example, if we have a 10-bit AD converter in an Arduino Nano, for example, then that will show you maximum 4-digit integer. And then initial value, let's say 1023, because that's the highest value. And if you want to check the display, if these values will show anything, you can do this without uploading the contents to the display. And you do it by going to the display, and then you go to the preview from current page. And then it says that make sure that number 0 font lib exists. And that is because we haven't copied the files to the corresponding places yet, and we haven't generated the project. So you see that the display is already there, but the values are not. So I exit this, and then I have to go back to the file, and I have to generate this code here. So all the values are set up what I wanted to have. So VP address, color, font size, and number of digits and initial value. So we can check this without the need of uploading the code to the display. So I just go to the display and go to the preview from current page. And you can see that we see our pre-made value. That's the initial value here. That is printed there. So that's really nice. So then do the same exercise with the slider value, and we can cheat here. I just click on this, and I can duplicate this by Ctrl-C, Ctrl-V, you can see, and I just drag it over here. But now, of course, we have to change the values of this, because it has exactly the same parameters as the previous control, and that's not good, because now they try to access the same RAM address, but I don't want them. So I change the VP address to, let's say, 1000. It's a kind of an arbitrary value, so that will be it. And I choose this as 1000 as the maximum value. So this is fine. And let's check this also. And you can see that we have the slider value and the ADC value both on the display. So then I said that I wanted to add the slider. So I go to the touch control because I want to touch the display. And then I have this drag adjustment. So I select this, and then I, let's say, make a bit smaller field here than the green band. And now on the right side, we have a different menu here. So then I leave everything like this, but I click on this data auto uploading. And this will mean that whenever we touch the display will automatically send the value to the serial port. And then we can give a VP address, and here I actually want to have 1000 as the VP address, so it has the same address as this value. And why is that important here is that whenever I modify this touching area or slider, then the value of this slider will be written under the VP 1000 address. And then upon that point, this field will also access, this field will only read that address, will access the VP1000 address in the RAM, and that means that whenever the slider updates the value of this variable in the RAM under this 1000 VP address, then that value will show up in the slider value box. So that's very nice. And also, since I put this check mark here, the serial terminal will show you a value which is coming from the VP equals 1000 address with the value of the position of the slider. Dragging mode, I think this doesn't need any kind of explanation. You can see what are the options. And then start value 0, that's on the left hand side, and let's say the terminated value should be 1000. So this is the value which will return when you touch the very end of this drag part. Let's try it. So now I'm just clicking, but I can do this. I'm dragging the mouse left and right, and you can see that the number is immediately updated. And when I reach the very edge, that should give us 1000. And then I should be able to go back to 0 if I'm not too clumsy. Yeah, I'm clumsy. So, but you can see that it works. And finally, we have this button, and here I go to touch control and return key code. So I just draw the control over this. I can also adjust the size a little bit. It doesn't matter here. It's not too sensitive. So then again, we have this data auto uploading. So whenever we touch the button, the value associated with the button will be sent to the serial. So we leave this checked. It has to be checked. We skip these two boxes because we don't have multiple pages. And then the value of the key should be, let's say, 001. So whenever I touch the button, the 001 will come from some address. I haven't yet given an address to this control. So we had here 2000. This was 1000. So let's make this 3000. Again, these are very arbitrary values. Read the manual if you want to get more deeper, or read the instructions on my website as well. So then this is done. And of course, I cannot try this now because I cannot read it. But what I can do at this point is that I can generate all these things. So I go back to File, Generate. Okay. And I save it just to be sure. So now I open the folder again from the File Explorer. And this is my YouTube demo folder. And initially I copied the font file here, but it has to be in the DWIN set folder. So I open that folder, and you can see that after generating the files, we have all these files: the font file, the touch, the display file, the config file, and the background file. But this is not entirely sufficient for uploading because one file is missing. I discovered some kind of bug or some funny thing in the software, which will not allow you to automatically receive the data on your serial port whenever you touch the dragging adjustment here, the slider or the button. So let's go back to the tool for a few minutes. So here I go back to the welcome display, and I open this UART download tool, and we have this CFG edit tab. So this is actually the configuration file which determines how the display behaves. And what I discovered is here, touch sensitive variable changes update. And for some weird reason, this is non-auto. I think by default it should be auto because it's not that obvious that you have a touch display and it's not sending any kind of touch commands. I mean, for me, it would be so natural that if I have a touch display, its default behavior is that if I touch it, it will interact with me and it will send the values and stuff through the serial port to whatever device which is connected to it. but it seems like the default setting is not like that. So put this into auto. If you want, here in the touch sound, you can disable the buzzer, and you can do any other funny things if you feel like experimenting. But the only and most important thing that you have to choose is this. And then we click on this new CFG. So we get this folder, and luckily we end up in the project folder, DWIN set. And according to the manual, we have to call this T5L CFG, and then it will be saved as CFG. So I just press save. Then I close this and go back to the files. So now we have the files available. So we want to upload this stuff to the display, and that is done by using an SD card. And the SD card has to be prepared for this task. So let me connect an SD card to my computer by an SD card reader, and I will show you how to prepare the SD card for uploading the code. So here's the command prompt, and we have to type in the following lines or line. So we have to format and -Q, and then here comes the letter of your drive. Be careful about this, not to erase something else. And then J semicolon dash again FS FAT32 dash A. And so once you entered everything, you just press enter. And then it's asking for this. So you just press enter again, since the drive is already attached to the computer. Then it's trying to format it. And I just call it DWIN. And we are done. So let's go back to the File Explorer. So then here I have the DWIN drive, as you can see. It's a FAT32 formatted drive. So here we need to create a new folder, which is called DWIN_set. You have to create this folder because the display will look for this folder on the SD card when it is trying to fetch the setup files. So then you open this folder, and then you copy the project files into this folder. So for the sake of simplicity, I just took another window, and you can see that we have these 6 files. So I just copy this over my SD card. And it's done. So now this SD card can be ejected, and then we can put it in the display. So here is the display. I tried to crop it in a proper way so you can see it how I interact with the display. So I just use the SD card reader and put the SD card in. And there you go. So now I connect the display to the USB. And now this is when the code is being updated or uploaded to the display. So we have to wait. There is a process going on. And now you can see that the process is finished. So then we have to remove the USB, and we have to remove the card. And now I can plug in the USB again. And there we go. So now we have the display, and we see the values, and then now we can start communicating with this display. So as I said, there will be a few options which I want to show you here. So one is the ADC value. Now in this demo, it will be just some random value that I send from the serial terminal. And I will just demonstrate how we can communicate with the display from a serial device towards the display. And then we have the slider value, which will represent one type of communication from the display towards the serial port. So this is the opposite direction as the previous ADC value. And then we have this LED button here, which will again send a value to the computer or to any kind of serial device that we are using with with the display. So for example, an Arduino microcontroller. So what I'm planning here is that you can see the real terminal software on my display. And I set it up in a way that it is showing the hexadecimal values, because that's how the display communicates with the environment. And we will see what kind of data is received, and we will also send some kind of data to the display. So first, let me just touch the slider somewhere. So I'm touching it. You can see that the slider value immediately changed to 573, and you can see that we received something on the display. And I will enlarge these values, and I will tell you what means what. So the first two, let's say, groups, 5A, A5, those are some kind of frame headers that is always received or has to be sent to the display when we communicate. And then we have the 06, which is the number of bytes sent by the display. And then we have 83, which is actually the number for the reading command. So if you want to, let's say, forcefully read something from the display, you have to send 83 to it. But otherwise, this character can be also 82, which is the write command. So if you are sending something to the display, then you will write 82. And then you see 10000, and that is actually the VP address which we used for sending this value. So this value, which is sent from the display, is coming from the 10000 VP address. And then when you are reading from the display, there is another value there, the 01, which is just simply the number of words being sent from the display to the serial terminal. And then finally we have the value 0 to 3D. And we can check this with our calculator, for example, if it's the right value. So as you can see it on the display says 573. And if I convert that into hexadecimal, you can see that that is 23D, which is this value here, 0 to 3D. So that's the same. So yeah, this thing works. So now I will just press the button to show you the other functionality. And you can see that again we received 5A5, which is the header, and then 06, which is the number of bytes being sent by the display. And I did not mention in the previous explanation, but the number of bytes is the command in this, let's say, code, or in this message. The command is 83, so that is 1 byte already. And then we have 3000, that is the address, the VP address of the button. You can actually see it in the background on the right hand side here. That is the key code VP address, so that's correct. So these are again 2 bytes, so we have now already 3 bytes, and then this is the 4th, 5th and 5th, sorry, and the 6th byte. So 01 again is just the length in words of these 2 bytes, and you know 2 bytes is 1 word. And then 0001, which is actually this very same key value here. So it works. But now comes the, let's say, more difficult part. We have to update the ADC value somehow. So then I go to the send, and here I just send a value to the display. So I have this small text box here. I might cut this and crop this to show it in better resolution in the video. But we have to send the header, and we are sending hex numbers again. So I will have to start with 0x and then 5A, and then I write a space, and then again A5. And then number of bytes, I know that I'm going to send 5, so 05. And then I'm going to write, so 82 is the command. And then we know that the ADC value this guy here, is stored under the 2000 VP address. So I do this. So this is the first part of the VP address, and this is the second part of the VP address. And then let's send something to the display, some value, let's say 987, and that in hexadecimal system is 03 and dB. So I will try to send this. Ta-da! It showed up properly on the display, as you can see. And now I just randomly change these two characters. I have no clue what this number will be, but I send it again to the display, so you can see that we can send anything, anytime to the display. So now it's 769. And you can see that whenever I send something, now I'm just going to flood the display, always the same message is coming back from the display. And that has no meaning at all for us, except that it is an acknowledging message that, hey, I got the message, and that's all. So we don't have to worry about this. But here you can see that we can write basically anything here, which makes sense, of course. And then we can manipulate the values here in the ADC value. So when you, for example, use a microcontroller, then the microcontroller has to create this kind of serial message. And then this serial message has to be sent to the display. And then the display will know that, oh, I got a new fresh value. Let's update the corresponding part on the display. So yeah, this is the first, let's say, video of this series, because I want to make this into series. I see a very good potential in these displays. They are extremely good, I think. They have very gorgeous colors, very good brightness, and really high resolution. And I think they are cheap. They are cheaper than their competitor. I'm not going to tell their names, but you know who I mean, or who I'm talking about. Those are also touch displays. So it is very nice display. It is very cheap display, but you have to pay with your time. It took me quite a long time to actually come over this learning curve to understand how this display communicates with us and how we can communicate with the display, and so on and so on. But once you get more familiar with the concepts, then you will get more and more comfortable programming this in more and more sophisticated way. So they have a very, very good handbook. You can see it's nearly 200 pages, and then they write down everything about the display. So if I skipped something in my tutorial, it's pretty sure that you will find it here. And of course, they have more details described that I was talking about in my tutorial video or introductory video. But yeah, you can find anything here if you get lost. Or if you want someone to explain these things to you, because actually some things are not that clear for those who are not experienced with these kind of things, then please subscribe to my channel and yeah, stay tuned, because I will do more and more videos on this display. I will do some kind of series, and I will try to show you more and more functionalities of this display and create more and more advanced user interface. So once again, thank you DWIN for supplying these displays to me. I will use them a lot, and I will make very good use of them. So you will see more and more videos about this, and hopefully this will help more and more people to understand how this display works and how they can work with this display. If you found this video useful, please consider becoming my supporter on Patreon. And also don't forget to visit my website, link is in the description, because I also wrote an article about this video. So if you don't like to listen to me for an hour or something, then you just follow my article, and I tell almost the exact same things in that article which I told in this video. So I hope that this video was useful to you. I hope you learned something, and see you in the next video.